So when we convert points, a lot of times we have to recognize that you're polar, going to rectangular, or rectangular to polar. So take a look at this point, 0, 5. Does that look like an r theta or an xy? An xy. So put above it xy. You know what x is, you know what y is. Well, we're going to try to figure out what it would be polar. So I'm going to do it two ways. I'm going to do it in a way that's kind of conceptual, and then I'm going to do it with a formula. So draw a unit circle, and show me where that, on that circle, 0, 5 might be. Show me with your arms where that might be. 0, 5. Up the top, right? It's probably going to be here. 0, 5. Well, how far out is that from the origin? 5. R is 5. What angle is this? Pi over 2. You got it. So this is going to be 5 comma pi over 2. That's what it's going to be. Now, wouldn't it be nice if there was a formula that you could just crank those out? Well, there is. And we're going to go to this yellow slide, polar rectangular form. This is how easy this is. You have an x direction, y direction. We always had a coordinate, x, y. And then we have an angle, theta, and an r, just the hypotenuse. Usually it's 1, but we can use it anything we want. What is the cosine of theta using either r, y, x, some combination of those? Turn to your neighbor, tell them what cosine theta would be. All right, so cosine of theta is x over r, and sine of theta is opposite over hypotenuse, y over r. Well, if you do a little cross multiplying here, you'll see that x times 1 is x, and r times cosine theta is what that's equal to. What will y be equal to then? R times sine. This is the formula that we're going to use to go from r theta to xy. And this is what they call polar to rectangular. Easy. And you don't have to memorize the which is which, because you just look in my formula, the two things that I have are going to be my knowns, and I'm finding these unknowns. And I'll give you all the formulas, but they're easy. Let's keep going with this. Let's do one more, and that is, what's the relationship between x, y, and r? What's the relationship? X, y, and r on this triangle. This is a right triangle, by the way. Yeah, x squared plus y squared equals r squared. So r is going to be plus or minus the square root of x squared plus y squared. So if we knew x and y, we could find r. And then the other one is, what's the relationship between these three in a right triangle? Tangent, yeah. Tangent of theta is opposite over adjacent. So theta is going to be the inverse, there's our inverses again, y over x. These formulas here are what we call going from xy, those are my knowns, right, to r theta, which is going to be rectangular to polar. And we can convert points and we can convert formulas. We'll do both of those. And then those formulas are up on the board. You'll have those for a test coming up. I'm not going to make you memorize those. All right, so let's go back to the point that we had. X is 0, y is 5. So if we have x squared plus y squared equals r squared, well, 0 squared plus 5 squared, r squared, looks like r is just going to be 5, isn't it? Oh, that's what we said. And then the tangent of theta is y over r, which is 5 over 0. Well, take your calculator. What's 5 divided by 0? Undefined. But if you looked at the tangent, when did we have undefined after 0? Where was it undefined? Pi over 2, right? There it is. You got it. Well, let's do some that are probably a little less conceptual, a little more formula-based. Try this one here. X is 3 and y is square root of 3. So r is the square root of x squared plus y squared. If you don't mind, I'll write the formulas first. So you get 3 squared plus root of 3 squared. That's going to be 9 plus 3, which is the square root of 12. So this is my xy. My r comma theta will be square root of 12. Now all we need is the theta. Well, theta is the undoing of tangent of y, which is square root of 3, over x, which is square root of 3 times the square root of 3. Mind if I did that? Anybody object? Jacob, you object? Oh, good. Good. Concur? Very good. So then this is just going to be 1 over the square root of 3, and 1/2 over square root of 3 over 2. This was y, this was x. What arc length does that connect to on the unit circle? You go over square root of 3 over 2 up 1/2. Is it pi over 3 or pi over 6? Pi over 6, yep. So there you have it. Theta is pi over 6. Now, if you have your calculator, just go ahead and put this in your calculator. 1 divided by square root of 3 inverse tangent. In the degree mode, you'll get 30. That'll work too. You try number 40. I want to see if you can do that. And I'm going to answer this question before we move on. Question was, why couldn't it be 7 pi over 6? And the answer to that is it really could be. But there's a rule I haven't told you about yet, and that is that in polar graphs, the angles are never bigger than pi and never less than negative pi. It's kind of like a norm. And so if you were to see 7 pi over 6, it's not wrong, but they would rather that you subtracted 2 pi and made it, I'm thinking of 2 pi. Subtract pi, 6 pi over 6, and then that gives you pi over 6. They prefer that it's that. If you get this far and get 7 pi over 6, I'm probably going to give that to you because I want you to get closer to the, we're not quite to that point yet, but we're getting there. So try 40. All right, so we still have r is the square root of negative 3 squared plus negative square root of 3 squared, which is the square root of 12 again. Theta is going to be the inverse tangent of y. Here's y, and here's x. This is interesting. This is going to be the inverse tangent of 1 over square root of 3 again. How can that be, though? Because both of these are negative. Negative 3, negative, this is where it is. Well, the reason is that when you do inverse tangent, it's going to give you the negative pi over 2 to pi over 2. So this pi over 6 is really what for this coordinate? What is that? Yeah, you're going to just subtract pi, and that's going to give you pi over 6 minus 6 pi over 6, which is 5 pi over 6. I think that's tough. Negative 5 pi over 6. This coordinate is going to be square root of 12 negative 5 pi over 6. Now, if you mentioned about this negative, why couldn't it be negative square root of 12? it could be negative square root of 12, and then this would be pi over 6. A little confusing, but it works. All right, go on to the homework, and we're going to launch right into the homework here. So here's 14 and 16. You're going to get the 4 different points, or 3 other points. Let's try 17 and 18. This is r, and this is theta. So what you're going to do is you're going to figure out what x and y are. X is our cosine theta, so that's going to be r is 5, cosine is 7 pi over 4. Then y is our sine of theta. That's going to be 5 cos, or sine, of 7 pi over 4. So I guess we got to know what 7 pi over 4 is. 1, 2, 3, 4, 5, 6, 7. There's 8 pi over 4, so it is back 1. 1 over square root of 2, negative 1 over square root of 2. And this is my x, and this is my y. So this is just going to be 5 times cosine is which one, x or y for cosine? X, 1 over root of 2, and then this one's going to be 5 times negative 1 over root of 2. So the coordinate for number 17 is going to be 5 over root of 2, comma, negative 5 over root of 2. This is the rectangular form. You try 18. 18 should go great. And this is the last thing we're going to do. We're going to change formulas from, in this case, we're going to do rectangular. Y is r sine theta, and negative x is negative r cosine theta. So all we're going to do is we're going to convert this into polar form. Well, notice that the r's are going to cancel, and you're going to get sine theta equal to negative cosine theta. Now we're going to make one function out of this by dividing by cosine theta, a weird thing to do. And you're going to get tangent theta equal to negative 1. Now, theta is the inverse tangent of 1. What would that be on the unit circle? Inverse tangent was 1. Where would that be? Pi over what? 4. It's right in the middle, right? So if it's negative 1 instead of quadrant 1, where are we going to be? Quadrant 4, actually, and 2. We'll get both of them, but this is negative pi over 4. So this is going to be theta is equal to negative pi over 4. Isn't that weird? And what's neat about that is that goes through here. What's the slope of this line? What's the slope? Close. Negative 1, right? What's the slope of negative x? Negative 1. Makes sense, doesn't it? Math works. Incredible. You try C here. You've got the technology. Go ahead and do it. Y equals x squared. Our sine theta, our cosine, squared squared. Divide one of these r's out, and then I would divide by cosine squared. So you might say r is sine theta over cosine times cosine. That's what some people would do. But you're kind of fancy. What's sine over cosine? Tangent. And what's 1 over cosine? Been a while. Secant. Yep. That's the formula that's probably the most accepted. So that's converting a rectangular equation to a polar equation. This one I would just square first. Minus 6x plus 9 plus y squared equal 9. And then you would take it from there. It's easy. All right, let's do these real quick. Converting polar, r is the square root of x squared plus y squared. Equal negative 3. Square both sides. X squared plus y squared equal 9. Now what shape is that in algebra? Make it with your, there you go. It's a circle, right? Center 0, 0. Radius what? 3. Look at this. What's the radius? 3. Works. Perfect. Let's try this one. Theta is 4 pi over 3. Here's a way to do this one. You don't have to, but I like it. I would do an inverse tangent of y over x is theta. Then that's equal to 4 pi over 3. And then if we take the tangent of both sides, this will be tangent inverse tangent of y over x. What's that? Simplifies to y over x. Isn't that beautiful? And then tangent of 4 pi over 3 on the unit circle. 4 pi over 3 is here. The coordinate is negative 1/2, negative square root of 3 over 2. I think if you do the tangent of that is negative square root of 3 over 2 y over x. What happens to the 2's? They're gone. This will be the square root of 3. Y is square root of 3x. Sorry about doing that so fast, but on the video this will flow pretty nicely. So that's what you do. You substitute in for r, substitute in for theta, and sometimes you do both. And I'll let you play around with these. So for tomorrow, you're going to do these two. Give me 3 more ways to write those. Convert the polar. These two, 36 and 29, you might want to sing a song while you do that one. Right. For 58, 62, 70, you're converting those to polar. Here you're going to convert these to rectangular. For this one, this yellow one, try these. Okay, but I'll go over them with you if you need help, because these are meant to challenge you. These are great R3s. These are great R3s. So we'll get there. Try them. And that is converting polar to rectangular, rectangular to polar, both points and equations.